In this video, we would like to derive an expression for the coefficient of apparent expansion and real expansion of a liquid. I'll start that by defining what they are. Liquid has two different kinds of expansions, that is apparent expansion coefficient and real expansion coefficient. Apparent expansion coefficient is defined as ratio of apparent change in volume to its original volume per 1 degree centigrade rise in temperature. So I can say V2 minus V1 by V1 of delta T. So where V2 minus V1 is expansion as that appears to you, right? I will explain what's the meaning of that. Similarly, coefficient of real expansion is real change in volume to its original volume per 1 degree centigrade rise in temperature. That is V2 minus V1 not apparent but real by V1 of delta T. We want to know what's the relation between these two, right? So let us take a container. Let us take a liquid in that container. Let us assume this container is having a long neck, like a specific gravity bottle. And this is the bottle where there is some liquid is. Let us take a liquid up to a certain position in that. Let it is filled up to a level A. Now let us put it on the stove. So first vessel expands when you supply the heat. As vessel expands, even before the heat is supplied to the liquid, heat is taken over by this solid container, and this solid also has some expansion nature. Therefore, before liquid expands, first the solid expands. As the solid expands, size of the solid increases. Thus, the liquid level actually falls down from A to B. So expansion of the solid has caused the fall of a liquid level from A to B. That is, gamma of that solid can be written like ratio of change in the volume of that solid container by volume 1 and delta T. So, what is the change in volume can be written like area of cross section into change in the length in this cylindrical long neck. Because all other parts up to here and all volume is anyway at the bottom part of that spherical part, volume is anyway is filled, and that's going to be there always there, right? So volume of increase in the volume can be written like area of this cylindrical part A increase in the length by original volume and delta T. So that can be written like area. Actually here level has not increased, level has fallen from A to B. Delta L is AB. Let the original volume is what V and delta T. From here I can write AB as gamma of solid. Take these terms to that side. Volume into delta T by area of cross section. This is all because when heated, container expands. But we will continue supplying the heat further as heat is further supplied. As heat is further supplied. Expansion of the solid container is limited. It's over. Now the heat is gone, further reached the liquid, and liquid expands, and liquid level rises from, actually it rises from B to C, but falling of a liquid level from A to B is not visible for you. A to B is not visible for a normal human eye because that is a small value. Thus for you, the liquid level appears like rising from A to C as the heat supplied. liquid level appears like rising from A to C, because falling of a liquid level from A to B is not visible for you. So the liquid still appears to you like it is at A. It rises from A to C. It is appearing like that. So that is a representation of gamma apparent. That is apparent change in the volume by original volume into delta T. That is area of that neck, and change in the length is from A to C by V1 into delta T. That implies AC can be written like gamma apparent into V into delta T by area of cross section. That is AC, measure of apparent expansion. Now, the liquid has actually raised not from A, rather it is raised from B to C, because liquid has fallen from A to B because of volume expansion of a solid. So you can write gamma R, real expansion coefficient of a liquid, as real change in the volume by original volume for delta T. Real change in the volume can be written like area of cross section into real change in the expansion of the liquid in the container length, that is BC, by V, and delta T is gamma R. From this you can write BC as gamma real into V into delta T by area of cross section. But if you notice the diagram carefully, the total BC is sum of AC and AB. BC is AC plus AB. I know the value of the BC already, gamma R into gamma R into V into delta T by A. I know the value of gamma A, gamma apparent into V into delta T by area of cross section. I know the value of AB also, gamma of the solid container into volume into delta T by area. So areas of cross sections are common, delta T's are common, volume initial is also common, all of them gets cancelled. You got gamma R equal to gamma A plus gamma of solid. You can also write gamma real of the liquid is gamma apparent plus 3 times alpha of that solid container. That's the relation between gamma R and gamma A. That's the relation between apparent expansion coefficient and real expansion coefficient. I want you to understand that all this is because a container is required to heat up a liquid. Without container, you cannot heat up. And when you supply the heat, first the container expands, which is not visible for you. So liquid level appears like rising from original level to higher level, but it's actually rising from the lowered level. That's the relation between apparent and real expansion coefficients. That's it. Thank you for watching. I also want you to understand that for a given liquid, gamma R is the constant. It depends on nature of that liquid. Whereas for a given liquid, gamma A depends not only on the nature of the liquid, but also on the nature of container. So gamma apparent appears like different for same liquid under different containers. For a given liquid, whatever the container is, gamma real is always same. That's how you have to understand their expansion coefficients. That's it. Thank you for watching.